that we're going to be using. Maybe, like this says down here, some other ways that we can write this equation. So if I have the equation 3x plus 1 equals -2, I can write that in several different ways. First off, we're going to get what we call the zero of the function, okay? Which means basically I just want the equation set equal to 0. So to do that, I could just add 2 to both sides. So I get 3x plus 3 is equal to 0. Okay, we really just call that the zero of the function. Remember, we've talked about functions. What is a function? Is where what? Each variable in the domain, or the x, is paired with exactly one variable in the range, y. Okay, remember that there's just an x and y. There's the x doesn't repeat, is kind of what we said. So that's the zero of that function. We might even call that, when you saw that, you can call it the root. It's all just another way of saying it. I could turn this around and write it as 0 equals 3x plus 3. That's not changing anything. And then remember, we talked about function notation. We could write that f of x equals 3x plus 3. Okay, that's just like me saying, no different than me saying y equals 3x plus 3. Those are all different ways of writing that same equation. We're finding the zero of the equation, and that's all that these really are. Okay, we're just saying it's the function notation. It's the way to write it as a function. We're mainly going to be using this, f of x equals 3x plus 3. So you're going to find it equal to 0, and then that's just you're going to put it into function notation. I know that may be a little confusing right now. Stay with me, and I think it'll make some sense. All right, so look at our first example. Solve each equation by graphing and check your answer by solving algebraically. All right, so I've already got it set equal to 0 in this one. 0 equals 1/2 x plus 3. So again, I can write that in function notation. F of x is equal to 1/2 x plus 3. So now let's solve this equation, and I have y in my chart, but that could easily just be f of x. But remember, we talked about that in function notation. That's really our y. Our f of x, our function notation there, is really the same thing as y. So either one you put, it's the same thing. You could write this as y equals 1/2 x plus 3. It's all really the same thing. Okay? So again, let's just graph this. We'll use a table. You could use intercepts, but we're going to just use a table. So it says to solve this equation by graphing. Well, when you solve the equation, the answer to the equation is where it crosses the x-axis. So if I said x is equal to, let's say 0, so I have up here 1/2 x plus 3. So 1/2 times 0 plus 3. My y is 3. All right, so my ordered pair is 0, 3. All right, maybe do some other ordered pairs. What if I did, just to make life easier, I'm going to do x is equal to 4, because I know when I multiply by 1/2, that's just going to be 2. And I don't want to have to deal with decimals if I don't have to. So 1/2 times 4 plus 3. Well, 1/2 times 4 is 2, and 2 plus 3 is 5. So my ordered pair is 4, 5. And again, just to make life easy for myself, I'm going to put in a -4, because then I know that 1/2 times -4 is just going to be -2 plus 3. And so -2 plus 3 is going to be 1. So my ordered pair is -4, 1. So now let's just graph those points. I've got 0, 3. So 0, 1, 2, 3. I've got 4, 5. So 1, 2, 3, 4. And then 1, 2, 3, 4, 5. And I've got -4, 1, 2, 3, 4, 1. Now, this is when you're really going to need to get your ruler out and make sure you draw good straight line because you need to see exactly where this crosses the x-axis. And I'm just going to do the best I can up here on my iPad. But if you'll get your ruler out, it'll be much easier on a piece of paper. Now my solution is going to be x is going to equal wherever my x-intercept is, where it crosses my x-axis. And so let's see, it's 1, 2, 3, 4, 5. It looks like about -6. So we solve that equation by graphing it. Now notice up here it says check your answer by solving algebraically. So let's solve that equation. Let's go back. Our original equation is 0 equals 1/2 x plus 3. I'm going to erase this part right here just so we have room. All right, looks like I'm frozen up here. Give me just a second. Hopefully we'll unfreeze. There we go. All right, so I'm going to subtract 3 from both sides. So I get -3 equals 1/2 x. What can I do to get x by itself? I can multiply by 2. And I'm going to get -6 is equal to x. So I solved it by graphing. Saw that x was equal to -6. And I verified that by solving it algebraically, like you've been solving it since pre-algebra when you were solving equations all the time. Now, I know you're thinking, why are you making me graph this when I can just solve it algebraically and be done with it? Well, if you'll just trust me and hang with me a little bit here, there's a reason. We're going to be solving simultaneous equations, 2 equations at one time by graphing them. It's just getting you used to graphing these lines and solving all different kinds of equations. Okay, you can do it algebraically or by graphing. All right, look at another example. Look at this example. It says solve each equation by graphing and then check your answer by solving algebraically. Well, that other one I had, remember, what have I got to do first? Really, to get it into function notation, I've got to have it equal to 0, right? I've got to find the 0 of the function. So I've got to get this one set equal to 0. So what am I going to do? Well, I'm going to subtract. I got to get this. Let's just subtract 2x by itself. From each side, excuse me. And it is by itself, actually, on each side. So then I get what? 5 is equal to 3. Can that ever be true? No, so it's just like before. What is that? There is no solution to this one. It would never cross the x-axis. There's no solution. There's nothing I can do that would make that true. Okay, so that was easy. Didn't even have to graph. All right, because I couldn't find the 0 of the function. All right, so look at this next one. Excuse me. Now look at this one. Again, I want to get the 0 of the function. So I've got to get it set equal to 0. So I think the easiest thing to do is to subtract 2 from both sides. So 0 is equal to 1/3 x plus 1. Again, I could rewrite that as f of x equals 1/3 x plus 1. All right, I can come down here on my chart. I know f of x is the same thing as y. Doesn't matter what you want to call it. And this is 1/3 x plus 1. And let's plug in some values. I'm always going to start with 0 because that's an easy one. So that's just 1/3 times 0 plus 1. Well, 1/3 times 0 is 0, plus 1 is 1. So my ordered pair is 0, 1. Maybe I'm going to try again. I'm going to pick numbers just to make it easy for myself so I don't have a decimal. Like I could pick 3. Because I know 1/3 times 3 is what? 1. Plus 1, so my answer is going to be 2. My ordered pair is 3, 2. How about -3? So I have 1/3 times -3, which is going to be what? -1, plus 1 is 0. So my ordered pair is -3, 0. Graph our pairs. Again, I've got 0, 1. I've got 3, 2. So 1, 2, 3, 1, 2. And I've got -3, 0. Draw my line. Now this one was pretty easy because I could tell by my ordered pair, right, where it was going to cross my x-axis. So my solution to the equation is my x-intercept, or where it crosses my x-axis, which is -3. Again, I could check that by going back to my original equation. 2 is equal to 1/3 x plus 3. I can solve that equation, subtract 3. -1 is equal to 1/3 x. Multiply both sides times 3 to get rid of that 1/3, because that's just going to cancel out. Let's try that again. That's just a mess right there. Multiply both sides times 3. So x is equal to -3. So I solved it graphically by seeing where it crossed my x-axis, and I checked it or confirmed that by solving it algebraically. Okay? So again, it's just a matter, you got to first find that zero of the function is what we call it. I've got to get it set equal to 0, and then I can go from there and I can graph it and solve that by graphing and then check it algebraically. Okay, one last example here. I just wanted to do one more of these. Kendra's class is selling greeting cards to raise money for new soccer equipment. They paid $115 for the cards. They are selling each card for $1.75. The function y equals 1.75x minus 115 represents the profits, y, so this is the profits, how much money they're going to make for selling X number of greeting cards. Find the zero of this function. Describe what this value means in this context. So if I want to find the zero of the function, I want to know what? Where it crosses the x-axis, or when the y is 0. So I'm just going to say 0 equals 1.75x minus 115. Okay? Let me say that again, because maybe that hasn't been really clear as I've gone through this. The zero of the function, all right, is when the y is 0, which is what? The x-intercept. It's where it crosses the x-axis. So now, to find the zero of this function, all I have to do is make the y 0, because I know what I'm looking for. My x-intercept, my y, my y is 0. So now let's just solve this equation. We could do it with a graph, but I'm fine if you just do it algebraically here. 115 is equal to 1.75x. Divide both sides by 1.75. And I'm going to get 65.71, and it's a whole bunch of other ones, is equal to x. But what does that mean? If y is the profit for selling the greeting cards, and I said y is equal to 0, okay, what does that mean? Well, they're going to have to do what? Sell about, I'm going to round that up, they're going to have to sell 66 cards to do what? Just to break even. They're not going to make any money, they're not going to lose any money, because my y is 0. My profit is 0. So they're going to have to sell 66 cards to break even. All right, then anything more than 66 cards would be the profit, would be when they started making money. Okay? All right, so that's solving by graphing. Again, you can always solve it by graphing and then check it algebraically. All right, have a great night. See you tomorrow. And what's the most important thing? You know what I say. Jesus loves you. Have a great night.